Okay, so let us start the second part. So this is also a problem in your book, but it is, I think, useful for the next part we want to do. It's good to have it in mind. So let G be a group, and let A belongs to G be an element of finite order for any integer n. The power A to the n has finite order, and the order of A to power n follows this formula. Okay. So it means that if you give me the order of A is finite, I don't know, let us call it m, and then n is an integer that you like, the question is that, is there any formula that I can calculate this order? Okay, that's the point of this theorem. You know something about the order of A, you know it is finite. You want to see what can I say about the order of that A to some integer power. And this formula tells you what that order is. And GCD, of course, you know what it means. So it means you take the order of A and divide it by the GCD of M and the exponent. Yes? Is that clear? Okay, so let us now try to prove it. I would recommend you to give some names to them. Okay, so if you don't mind, let me call this P. N is reserved for this one, so that's why I didn't call it N. M, N is reserved in the problem. P, I give it a name. And then GCD of order, so let me call D the GCD of OA and N. Because working with this combination all the time is messy. So GCD of this one, which means GCD of O of A is M and N. Okay? So I'm just introducing some letters to write this in a simple way. So my goal is to show that P is equal to M divided by, yes, this is what I want to show. Yes? So can you help me? What is the first thing I will do? You want to show that order of an element is a proposed number. What you should prove? For example, always try to learn to think in that way in mathematics. If I say, prove for me that order of G is 5, how do you confirm that this is a true statement? You have to do two things to convince me that order of G is, so you have to convince me that the order of G is 5. Can you tell me briefly, quickly? I'm just hypothetically saying that, okay, in the exam I ask you to prove that the order of some element G is 5. How do you in principle prove it for me? Yes, please.
Yes, you show that G to the power of 5 is E.
Yeah, number one. But this is not guaranteed that the order is 5. I have to show, number 2.
That it's the smallest number possible.
5 is the smallest possible integer. Put that right. Yes, that's the same thing. You see, this is the correct way of thinking about mathematics. Otherwise, you will be lost with the complication of formulas. So this problem in the book is nothing except that you want to prove. So they have given you so it means this 5 is playing the role of this, a strange combination. They have already proposed to you that this is the order. What you are supposed to do is just confirm that this is the order. And this is not the hard part of mathematics, because if you respect the definitions, you immediately know your strategy. If you do not have any strategy for solving math problems, then you are lost. You have to randomly manipulate things, which is not usually working. Okay? So my goal is to show that the order of this one is, okay, help me. The first step is definitely easy, usually the easy one. Here, I wanted to show that G to the power of 5 is E. So here, my question is that the first step, I show that AN, help me, to which power?
D.
M over D is equal to E. Is that right? because the order is proposed to me, I want to confirm it. The first step is I raise the element to the proposed one to see if it is E or not. Is that clear? Yes? Yes or no? Yes? Okay. But be careful, M over D is not a fraction. Is it a fraction or not? Because if it's a fraction, I am in trouble. In group theory, we have only integer powers. But MD is written as a fraction, but it is not a fraction. Why? Yes? Everyone?
Denominator.
Yeah, because D is the greatest common divisor between M and N. So it means M is divisible by N, M is divisible by D, N is divisible by D. So this is an integer. So I have an integer, I have another integer. We had a theorem last time, so I can multiply the exponents if they are integers, of course. So it becomes N, M, D. And what do you think I will do now? Can I write it in this way? I want to write it in this form. Of course, this I can do. Yes. But that, can I write it in this form or not? For doing this, I also need to make sure that N over D is also an integer, because I'm using the rules of powers only for integers. So is this algebra clear for you? Okay, but what is A to power M? Order of A is M. So what is A to power M? So it is E. E to a power, to an integer power. This is an integer even though it's written as a fraction, so it becomes E. So this is usually the easiest step. G to power 5 is E. That's the easiest step. The hardest step is to show that this is the smallest. This is the smallest number for which A to power N to that power becomes E. Okay. Okay. So in other words, so from here, I can conclude one more thing. Okay, I can also conclude according to what we learned is that, so let me write it here. So order of A to power N divides M over D. Do you agree with this one as well? I mean, this is on its own good. So I was able to show that A to the power of N to the power of M over D is E. So this means that the order of this divides this exponent. We just learned that. Let me rewrite it for you. So you remember if we have this A to power, so let me write it like this, is E. What we conclude, I wrote it in a box here for you. What did I conclude? I concluded that order of A divides N. And actually they are equivalent. Yes? So now what I have something to a power is equal to E. Yes? So what does it mean? It means the order of this box divides the exponent according to this rule. Is that right? Yes or no? Okay. So now what does it mean? But this one, I called it P. So this means that a P is definitely less than or equal to M over D. Okay, let me write it like this. Okay. Okay, number 2. So let me see, might be that's a better idea if I do it the other way around. So let me confuse you. Okay, so might be this is, so let us keep it. Yeah, I don't want to confuse you. So number 2, what I want to do might be that is not a good idea from the beginning. It's not wrong, but you see the hard part is I want to prove this is the order. I cannot grant anything about the order. Okay. So let me change my strategy. Okay, so So sorry for that. Let me change my strategy. I want to prove that this one is true. So let me get rid of fractions. Fractions are confusing. This is equivalent to saying that PD is equal to M. Yes. So instead of proving this, let me prove this for you. Okay. So well, that is good. So let me continue here. So this means that P divides M over P. Okay, so that's correct. So this means that PD divides M. That's correct. Okay. I have to prove it the other way around. So let me explain again. So I started from here, that was not wrong, and I conclude that this is E. I am using this box, which we had before, but from left to right direction to conclude this. I want to wait 1 minute. Do you feel that this is correct or not? Yes? Understandable for everyone? Or so some element to some integer is equal to E. When I have an element to an integer is equal to E, I can conclude the order of the base, which in this case is a to power n, P, divides the exponent up there, divides this exponent. Is that right? I am using this. But then hopefully you see that I can multiply both sides by D and I get this one. So let me call this one number 1. But my goal is to show equality. This is not a still equality, so I have to do some work. Okay? So to finish the job, I have to show that. Can you tell me? I want to finish this job. I have only this one available. I want to prove this one. What should I prove? I have to show that M divides PD. Do you agree? Because I already know PD divides M. If I can show that M also divides PD, I am also considering that M, yes, M is a natural number. So I want to show that if I can show this, still I don't know it, but this one together with that one will give me this equality, and this equality can be written in this way, and that's exactly my question. Yes? So we want to prove this. But what do you think I will do now? I just told you something similar to this before the break. This is a very standard technique in algebra. So if you want to prove this, yes? Use
this integer Q and R.
Yeah, division algorithm. So instead of proving this, I would say that there exist integers Q and R such that PD is equal to MQ plus R, and R is between 0 and M minus 1. Yes? If R is equal to 0, we are done. Because I want to prove this. If R is 0, I am done. So if R is 0, we are done. So let us assume that what happens? R is not 0. On the one hand, R is between 0 and M minus 1. If R is not 0, it means it should be between 1 and M minus 1. Yes? Okay, do you remember what was the trick? The trick was to calculate a to power r. Yes? And that is good, because what is the order of a is m. If I can show that a to power r is also m, I have my contradiction. Because this is the smallest number for which a to that power should be e. Okay? So this means that I will start calculating I to the power of r. So then, a to power r is equal. Instead of r, I can write PD minus MQ. Yes? So if you want, I am using this. But now, what do you think I will do? This is not a problem. This is a problem. It becomes a to the power of PD. This becomes a to power minus, M to the power of minus Q. Do you agree? I'm just doing simple algebra. But what is this one? Order of A is M. So this is E. E to power minus Q is E. Then I will have A to power PD. This is not bad, but this is not good enough. Because I want to have E at the end. Unfortunately, I have A to power PD. Okay, can you help me to continue? One more theorem is needed, which I mentioned the name of it in the first lesson, after division algorithm. They are very famous in number theory. They usually come one after the other. What? So let me write it here for you. So that is called Bezo's theorem, yes? So let me write it here, by the way, that's still part of the proof. So what is D? M and N GCD is D, yes? So GCD of M and N is D. What can I conclude? Bezo, if I remember. These French names are hard. Bezo's theorem. Okay? By Bezo's theorem, what I can conclude that there are R and S in Z such that Rm plus Sn is equal to D. Yes? So these are two very standard theorems, division algorithm and Bezo's theorem, okay? In elementary number theory. Do you think this is helpful now? So if I go from here, so let me call it number 1, and let me call it number 2. From number 1 and number 2, what I can conclude? I can conclude that A to the power of R is equal to A to the power of P, but instead of D, I put Rn plus Sn.
That's another R.
Yes, you are right. Let me change the letter. Yeah, because I have already used R. Thank you very much. Thank you. And this one. Yeah, that was actually very good. Yes? Because I have already used letter R. Thank you very much. Otherwise it was very confused. So, then of course I do this algebra, but let me do it in this way. Do you agree with me that I can write this? Let me do it in 2 steps. PRM, and then I have A to power PSN. Yes? I just want to make sure that you are following me. What do you think I will do now? Everyone agrees with what I'm doing. I multiply this P in, and I decompose it. But what do you think I will do now?
A to the power of M is identically A to the power
So you say that I write it as A to the power of M to the power of PR, and this one?
A to the power of P N to the power of P.
Yes, very good. So A to the power of N to the power of P to the power of S. Yes? Why do you think it is good now? Do you remember I told you this is good, but not good enough because I want to have E at the end. So if you don't lose your strategy, it is not hard to follow. That's what I'm saying. There are a lot of ways I can write, but this is the only one which will work because I already have a strategy in mind. Okay? So this means that if I ask you what is this expression, because order of A is M, so that is E. If I ask you what is this expression, it is E. Why? Where was it? The order of AN is P. So it means AN to power P is E. So that one is E, and doesn't matter which exponent I have. I hope that you agree this becomes E. But now, if I want to see how alert you are, but what should I say? Are we done? Are we done? No, if you will leave it like this, I will deduct some points from you. I promise. Okay? So you have to say something. Yes, please.
It's proven by contradiction, right?
That was the proof by contradiction. So what is the contradiction now?
That, well, this means that
A to
R,
power R
yeah.
is E.
Yeah.
Yes. But R is between 1 and m minus 1. And this cannot work. Because when you say the order is m, it means the smallest number for which a to that power is e is m. But I was able to find a smaller one that has that property. Is that clear? Yes? I feel some of you are not comfortable. Yes? Are you? Are you comfortable or not? Say something. You're not. But why don't you ask? It's so complicated, it doesn't even worth to ask. No, it's not complicated. It is very, very interesting. I mean, very beautiful. First you have to enjoy, you know? That's the first ingredient. Of course, if you don't enjoy mathematics, it's just a torture. So what's the point sitting doing these things? Or then what? Then nothing. I mean, then everything actually. Whatever you have comes from mathematics. You are very now interested in using AI. So that's mathematics. You have a spell check. We will talk about these metric spaces in analysis. You do a spell check all the time. It's just a metric that's calculating the distance between two words. Okay? So I mean, you are using mathematics when you wake up and take your phone, you are using math. When you zoom in, that's a linear transformation. As you zoom out, these are linear transformations. It doesn't matter. I mean, mathematics is really necessary. So that's probably the most applicable what we have. Yes, but you have. I agree with you because you know here we don't have that much time. I don't like this way of teaching. I'm going very fast because I didn't give you a lot of problems. Usually, when I finish a lesson, I have to solve a lot of examples before going to the next lesson myself, not just throwing everything on you. You know, because then you have to spend all the time I have spent to learn yourself to learn. But that's not the goal. I have to help you to go faster. Because you are not supposed to end at my position. You have to go faster because our problems in the future will be harder to solve. So you have to have time to reach at the point to do some research, to do something new. If you want to spend all the time I spend, you will end up with at the same position that I am. You have to be further. And then you have to do the same for the next generation to go further. That's how it works. Yes, I'm a little surprised. I mean, university, you have these kind of things background, and if you're going to be a teacher, learn these things. This will motivate students. Yes? So there is only one way to sit down and do exercises. I didn't spend 1 hour in the weekend to enjoy. Actually, I enjoyed all the time because I was doing these. I was making these notes. So that's the whole point. You have to find a way to enjoy your life, and I mean. If you think that this is not something you really like, you have to give up so easily. I mean, very soon. So what's the point? If you don't like something, you will destroy the next generation. You go to the, teenager students are already not willing to study, and then you are just motivating me. Okay, study is not something good. I agree with you because I'm also bored here. So you have to love what you are doing. Otherwise, it doesn't work. Okay? And I am open, so if you want, we can have some extra lessons here. But I will not go through the department, and I will solve all those checkpoints with you. Not solving it, but I try to guide you about how to think about the problems, because most of the time people don't even know where to start from. If you want to be a math teacher, you have mathematics is hard, okay? And even for me, and that is the nice point about mathematics. I challenge it because I want the challenge because I like it. If the mathematics is simple, so why didn't? So let us say that I have a Sudoku table. They give me the same Sudoku table every time, and I know how to solve. So what's the point? So the joy is coming from actually. Oh, can I solve? Can I challenge myself to this problem or not? No. And then the life becomes much harder. Most all of them can be solved by AI instantly, very precisely these days. I have checked all of them. And by the way, I am using the AI to develop these notes. So yeah, because I just type them and I just send them to AI to polish my English sentences and everything. So it's helping, and that's good. I mean, if mathematics is not there, I didn't have these. Yes.
I was curious about, is this an easy proof, would you say, or is it
No, if I remember the first time I tried to solve this problem, I could solve it, but not very easily. But the point is that when I was educated in Iran, I had a lot of these formulas in my head. And because that's the very bad thing in Sweden, people learn very good at spot, but they immediately forget. And then over time, you have forgotten a lot of things. And there is no way, I don't know why no one tells you about these things. There is no way you can imagine what to do. Okay, so you don't remember the correct form of the division algorithm. You don't remember the correct form of Bézout's theorem. And that's a minor problem, because you even don't know if Bézout's theorem is useful in this problem or not. So that is why mathematics becomes hard. Mathematics is hard even for brilliant mathematicians. But these things are not hard. You can learn. It's like, for example, understanding functions and I don't know derivatives and these things that you have learned is like if you are a plumber and you cannot use a wrench. It's a different. You can be a plumber and create a masterpiece. This needs creativity and genius. But you cannot say that I'm a plumber, but I don't know how to use the wrench. That is not acceptable. So if you haven't developed a correct feeling about what the function is, you have to live with the function. So when you see function, you have to feel what the function is. And this will not work first if you don't like it. And of course, the education system is also making some trouble because they don't probably present it in a way that you start liking it. It doesn't mean that everyone will start liking mathematics, and thanks God that this is not the case, because then we will not have any surgeons or any other occupations. And I would have, for example, I have been dead when I was 10 because of my appendix, That's good that some people don't like mathematics, they like something else. But if you want to do mathematics, my pre-assumption is that you're supposed to be a math teacher. So the first impression when I come to your lesson is that you already know you love mathematics. It means that you really cannot sleep when you cannot solve the problem. Many times I sleep behind my desk. I fall asleep on my desk. Now, this is something you have to learn. Yes?
I think for many of us, the hard part might be watching you solve the problem on the board than solving them by ourselves.
That's a very good one.
Yeah.
So if you sit down, yeah.
So
Yeah, that's very good. If that's the case, so that's my wrong impression. But if this is hard for some of you, I can help you. Please come to me and try to discuss. And if you need more help, I am willing to have, I don't know, but we will not be able to book this room because this will cost thousands of crowns for the department. So, but if I just come to the room, I don't know if they caught me and put me in the jail. I don't know about that. Oh, I recorded everything. But anyway, so let's see how it goes. Okay, so let us forget about that and then immediately start the next topic. I don't know, should I take this off from the recording or not? Anyway, so cyclic groups is another part of the lesson today. So what is a cyclic group? First of all, this is a simple theorem, very simple theorem. Let G be a group and let A belongs to G. The subset H equals to A to the nth, n belongs to Z, is a subgroup of G. Okay? For the time being, let us see that if this is a group or not, is a subgroup or not. So what I'm saying is that you give me a group, I choose an element from your group, from the group, and then I start collecting the powers, integer powers of A into a bag, into a collection, A to the n, where n belongs to Z. Okay? So is that understandable? So there are some group elements. So one group element, I choose it, and I raise it to any integer power possible. A to power 0, A to power 1, A to power 10, A to power minus 17, etc., etc. I put all of them in a set. This becomes a new set. Hopefully you agree with me that this is a subset of G. Why is that? Do you understand what's the meaning of subset? So first of all, tell me, why do you think H is a subset of G? What do I mean by this? It means, are you okay with that? Every element in this new collection already belongs to your G. Yes? Is that understandable? Because every element here is the nth power of a group element. So a to power n means multiply a by itself n times, or 1 over a to the power of minus n, whatever it is. So this is still in G. That is very clear. But one more thing is that this is not empty. Do you feel that this is not empty? Yes, because A, so in the worst case scenario, you just put A inside. So it's not empty. Yes? But you want to prove more than that. You want to prove that this is a subgroup. So do you remember we had three things to check? It is not empty, which we are happy with that. It is closed under taking inverses, and it is closed under multiplication. Yes? So is it closed under? So the first one, it means that if you tell me x belongs to H, I have to convince you that x inverse also belongs to H. Yes? This is simple. Do you agree why? Because if x belongs to H, what does it mean? It means there is an integer such that x is a to power n. Yes? Because the elements in H are of this form, and when you say x is in H, it means it takes this form. Okay, what does it mean? This means that x inverse becomes a n inverse, but this can be written as a to power minus n. But do you agree that a to power minus n is also in H? I'm writing it very quickly to compensate for that short time that I spoke. So a to the power of minus n belongs to H. Why? Because when n belongs to z, minus n also belongs to z. And any integer power of a is already in H. This is an integer power of a, it is in H. Is that right? So x belongs to H, y belongs to H. I want to convince you that x, y also belongs to H. Do you see that? When you say x belongs to H, what does it mean? It means x is a to some power, some integer power. I'm just making it very short. This means what? Y is a to some integer. And then when you multiply them, it becomes a to power n plus n. Do you agree this is an H? Yeah, because that's an integer power of a. It's an H. So it's a subgroup. This subgroup is important. We give it a name. This is called a generated subgroup. Okay? So let G be a group, and let A belongs to G. The subgroup in theorem 4, the last theorem, is called the subgroup generated by A, and we have a symbol for it. It is denoted by these angles of A, yes? Is that clear? So this is a subgroup, but we, instead of writing it with just H, we write it as the subgroup, the subgroup generated by A. So whenever you see this symbol, it means you already have a group, you have picked an element from your group, and then you can discuss about this. This is just a notation for this. What is the structure of this in algebra? It is a subgroup of the original. That is called a subgroup generator. Yes, please.
A generated subgroup, is that always a to the power of any integer, or can it be any, like, can it be another type of generation as well, like?
No, it means that you already have a group.
Yes.
So you pick one element,
Yes.
and you will start doing the binary operation on the group any integer number of times.
Yeah. Okay. Okay,
And
so
then you collect all these generated elements and put them in a set. That set is called the generated subgroup.
Okay, so specifically that group.
Yeah,
is the only
exactly.
one.
Understandable? Okay, so let us now go to the next one. So this example number 3, show and remember. That's good to remember. That if A is a group element of order n, there is a very simple, nice formula for the subgroup generated by A. Okay? So what I want to say is this. If you have G, a group, and you have an element in G, and then order of your element that you pick is n, then there is this nice formula that the subgroup generated by A is starting from a to power 2 up to a to power n minus 1. Okay? This is what we want to show. Because in principle, when you talk about the subgroup generated by A, you can also think about a to power minus 3. You see, I put n belongs to z. So negative integers are also included. But what I'm saying is that if you are lucky and the order of the element you choose is n, remember that this is the formula. But we have to prove it. Okay? So what is e here? If you want, you can change it with a to power 0. So you don't need to look at all exponents. You just keep exponents from 0, 1, 2 up to n minus 1. The rest of it will repeat these elements again. That's the whole point. Okay. So for example, what I was talking about in the previous courses, what do you think I want to do to prove this? Because that is important. I know immediately where to start from. Okay? This is not something, this is definitely something you can learn. If you haven't learned, I want to change the way you think about the problem. This is not of the hard problems. How can I prove this? Yes?
We can, so if
No, I'm talking about strategies. Don't go to the details. Details are tactics, techniques. I want strategies. So, what do you see on the right? What is it called in mathematics?
a set,
A set, thank you. The names are important. So this is a set. And what is on the left side?
a group,
It's a group, but before being a group, it is a set. So this equality is at the level of equality of two sets. This is what I mean by strategy. Okay, so this means that you have to ask yourself, okay, in my toolbox, what do I have when I want to prove two sets are equal? This is the correct question to ask. It is probably not easy to understand how to do it, but this is where you start. I have one set on the left, I have one set on the right. My goal is to prove the equality of two sets. This is the first thing I see when I see this question. And I ask myself, what is the standard technique to prove the equality of two sets? Yes, you.
Subgroup. They're
Subgroup,
both subgroups.
So you see, this is the correct way of thinking. If you learn how to think in this way, you will start learning, yes? So this means that immediately, I don't spend so much time. In a matter of seconds, I understand that I have, in the scratch paper, I give it a name because I'm lazy. Okay? And then I would say that I want to prove that this set is equal to this set. And in my toolbox, I know that my toolbox means memory. I have to prove this, and I have to prove this. Yes? And it doesn't take me that much time. This is what I want you to learn. And then, of course, I don't say immediately I can solve the problem because there are technical problems in the middle of the way now. Okay? But if you don't have a strategy, then what do you want to do? You just want to manipulate the data? Okay. So now, which one of them is obvious for you?
Sorry, what's the question?
Which one? Because this one includes all integer powers. So apparently in your mind, this one is a smaller. Okay, so sorry, this one is a smaller. Oh, sorry, no. This one. Yeah, that is obvious.
H
Yes?
is smaller. H is smaller.
No, the second one.
H is this one means all the integer powers. Yes, this one, yeah. Yes, that's correct. This one is obvious. Yes, because this one includes all integer powers. But this only has 0 power, first power, second power of n to n minus 1. So you see how the problem becomes simple. So this is done. My duty is to prove this one. That's it. Okay? So then, how should I prove this? Again, I have it in my toolbox immediately. I want to prove a set is a subset of the other one. What is the standard way? Yes?
There it is, non-empty is closed under the
No, that's a subgroup. This is subset. Yes?
Show that all elements are in H.
All elements of the left side is in H. So what does it mean? In the exam you say let X belongs to this. I prove what? Tell me. X belongs to H. So you see it's starting, it's working. If the problem is extremely hard, you get to start, simple as that. Okay? But at least you know where to start from. Okay, so now how should I do that? And then again, if I want to start from here, I want to say something. What do I need to say something? I want a word from you. In mathematics, I want to go from here to the next step. I need what? A very, very, very important word in mathematics.
Implication.
No, that's the implication. It implies what based on? Let me write it for you. Do you agree with this one? Do you agree with this one?
Definition.
Sorry, by the way, let me be careful. N is reserved for this one. Do you agree? Do you agree with this one? Why?
Definition of
That's the word. So you know the definition. So X belongs to this symbol. So before coming to this class, let us say that you didn't know about this. So what do you want to do? The first question is that, Babak, what is this guy? So, but when I ask you, you cannot answer. You have to organize your brain. So when I go from here to here, that's definition. So this is the definition. No one will ask you why, because based on the definition, is that correct? Okay, but now, but this is M. It is an integer. There is no guarantee this M is one of them. If you are lucky, M is 0, 1, up to at most n minus 1, you are lucky. And life is not that simple always, most of the time, okay? So we are not usually that lucky. So it means that I have to convince myself I can reduce this M to one of these. So what do you think I will do now? What do you think?
Assume the contrary.
What?
Assume the contrary. Maybe.
So assuming the contrary, at least I don't know how to do it. But what was the standard trick we learned 2 times today? Yes?
division.
Division algorithm. Okay? So you start dividing n. So can you tell me how I use the division algorithm?
Divide m.
Because my remainder is supposed to be one of these numbers. So I would say that, again, you see I am using the same trick over and over again, and I'm lucky I'm getting money for it. That's the whole thing, yes? So you also learn these tricks. So what happens is that xm, you would say that there exists R and Q where in Z, such that what happens? M is equal to NQ plus R, but R is between n minus 1. Do you agree? Okay, at this stage I was very happy. You know why? Because I have 0 up to n minus 1. So it means that I am on the right track. Yes? So how can I proceed then? From here, I would say that x is equal to a to power m. Instead of m, I put this guy. Yes? And then hopefully you know how should I divide it by now. Yes? And then what is a to power n? E. So it becomes a to power r. So even though this is a to power m, but I was able to reduce a to power m to a to power r, in which r is one of these integers, 0 up to n minus 1, and I am done. So this problem is an extremely simple problem, but it was very important because you learned a lot of things, and it's important to remember these tricks. I am not saying to remember everything I have done, but these are strategies. Proving equality of 2 sets should come to your mathematician mind in a matter of 1 second, no more. If you spend 2 seconds, it means you haven't done your job. Yes? Well, I'm exaggerating a little bit, but this is something you need to immediately understand, and especially people don't respect these definitions. You have to say that based on definitions what I'm doing. Yes? So if you collect all these things, then probably you will learn mathematics at the end. And then of course you will enjoy it, and when you enjoy it, you will go faster. Okay, I'm waiting for you now. So,
Jaha, yeah.
so is that clear from now on? So we have a nice formula for the subgroup generated by A if A has a finite order. Just write A up to AN minus 1. Now can you see this? Can you feel it? So let me read it for you. So note that this order is equal if A has finite order. So I have given you the hint. Forget about this, okay? So let us see what is the meaning of this. First of all, do you see the difference between this O and that O? Yes? You feel the difference between these O's? Yes? This O is for a subgroup, a group. It's order of a group. The order on the left is order of an element of a group. But my claim is that order of the element A is always order of the subgroup generated by A. Okay? Why is that? Let us consider the case, so because it's already on the board. Yes? If order of A is n, we are done. Why? It's on the board. Count them. 1, 2, 3, up to n. So if I ask you what is the order of this, you will start counting 1, 2, 3, up to n. So order of this is n. And order of A is also n. So if order of A is finite, these two orders are the same. A very, very nice, innocent, beautiful, elegant formula. Okay? You have to remember this. And let us think, I want you to think about it yourself. What happens if the order of A is not finite? It means that this is infinite. You should be able to prove that this one is also infinite. It's very simple exercise, okay? So do it yourself, please. Oh, sorry, I didn't record this part. Okay, so a group G is called a cyclic group. Okay, that's also very important. A group G is called a cyclic group if there exists an element in G so that G becomes the group generated by A. Okay? So, I mean, it's easier to do examples. Okay? Show that U10 under multiplication modulo 10 is a cyclic group. Okay? So let me repeat it for you again. So what is U10? Can you help me to write it? So what is U10? It starts from 1, 3, and 4, no, 5, no, 6, no, 7, and 9. Yes? This is the U10. My claim, according to the problem, is show that U10 with multiplication modulo 10 is a cyclic group. What does it mean? It means you can find a generator for this. It means that you can find one of these elements for which when you calculate this for that element, it becomes the whole group. It means my group is cyclic. Okay, is that clear? For example, if I start to find A, to find 1, so 1 to power 1 is just 1. Okay? So 1 to any number is 1. So if I ask you what is this 1, what do you write here? There's only one element there, and that's 1. Yes? But this did not generate the whole set. But it doesn't mean I can immediately say this is not cyclic, because it might be another one of the elements can generate the whole set. So let us check. We have to check all of them. Okay? So number 3. So can you tell me what is 3? So it is 3 to power 0, and then 3 to power 1, which is 3, and then 3 to power 2, which is 9, and then 3 to power 3, which is 27, but modulo 10 is 7. So let me write it 3 to power 4, if you don't mind. And then what happens? This becomes 1, this becomes 3, this becomes 9, this becomes what? 7, and this becomes 1 again, and that's end of the story. So let me move it. And then suddenly you see that the whole group is generated because the order doesn't matter. So this is U10. And here you can be relieved. You can say, can I say that U of 10 is cyclic? Yes. And then, which one of them is a generator?
3.
3 is a generator, because it generated the whole group. Is there any other generator? Might be. Let us check. So 1, 7, 7 to power 2 module 10, 9, 7 to power 3 module 9, 3. Oh, beautiful. Another generator. Yes? So, but one of them is enough. To just say that this group is cyclic, one of them was enough. But this group has 2 generators. What do you think about 9? What about 9? 9 to power 0 is 1, 9 to power 9 is 1. 9 to power 2, 81 is 1 again. Finished. So that is not a generator. So this is a cyclic group with 2 generators. 1, 7 and 1, 3. This is a cyclic group. Yes? And for example, just tell me, if I write U8, what happens? This becomes 1, 2 is not there, 3 is there, 4 is not, 5 is there, 6, 7 is there. Okay? I have asked you to show it is not cyclic. I don't want to solve it, but can you tell me how should I prove it in the exam if I give you this and I ask you to show it is not cyclic? Here I ask you to show U10 is cyclic. If you want to show it is not cyclic,
It's the same, right?
you have to do this for everyone and confirm none of them gives the whole thing back. Is that understandable? So conceptually it is understandable, it's not hard. Is that clear? But there are more theorems to come. I don't know how to finish the course, but let us see how it goes. How it goes, okay? Any questions? No? Okay, see you tomorrow for those people who are coming. Otherwise, I hope that the recording is well. I will upload it. Thank you very much. Thank you.